Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 122. Quick reminder, please follow us on LinkedIn to support the live stream. Our guest today is Neha Rungta, Applied Science Director of AWS Identity, and Rohit Kar, Zentarati, and our first three-time guest, having previously appeared on episodes 19 and 73. Welcome, Neha.
Thank you. Great to be
And
here.
welcome back, Rohit.
Thank you.
So we normally do intros, but Rohit, you already introduced yourself in episode 19. So in the interest of time, I'm going to refer listeners back to that episode. We're going to skip your intro today, but Neha, why don't you tell us a little bit about your career and how you ended up leading this great project at Amazon?
So, if I were to think about the three chapters of my career, the chapter one I title NASA to the Cloud. And I began my career as a research scientist at NASA Ames Research Center in the Bay Area, where I worked on verification of unmanned space systems, air traffic control systems. And I was really passionate about how do we apply formal methods and automated reasoning to mission critical systems. In chapter two, I took a huge leap and moved to AWS security and working on security for the cloud. And the fun part was I knew nothing about the cloud. I did not have a background in security. And that was the big leap, the big dive I made. And from there, chapter three was building and launching services like IAM Access Analyzer, verified permissions, which was taking some very deep science into scalable customer facing products. And the key being, nobody had to be a logic expert or an automated reasoning expert or even an identity or security expert to be using these services and getting the benefit of them.
And well, thank you for that. So today's format's a little different. I recruited Rohit because I felt like this topic maybe was a little bit more technically difficult for me than most. Rohit and I are going to collaborate on some questions. I'm going to let Rohit. You want to start with our first question? The topic today. So the official topic is title is Cedar versus Rego versus OpenFGA, but we're going to broaden that a little bit. We are definitely going to talk about we're going to hit those points, but I think we're going to start a little bit before and probably go a little bit beyond the actual title. So Rohit, why don't you start with our first question for Neha?
Absolutely. I think the title is about these language barriers. And for those of us who are working with the community to promote new externalized authorization schemes, the industry trope is that we have a bunch of startups and a bunch of different languages, and everyone wants to get into the battle of X versus Y versus Z. And it's rare that you have not necessarily a feature comparison, but one camp or one approach that has a very different fundamental philosophy of the product than the other things. It'd be like if only one database in the world ever decided to believe in relational algebra and did SQL.
Yeah.
And so on that basis, we're diving right into what, of course, I'm putting my thumb on the scale is the most important difference about Cedar versus Rego versus OpenFGA, which is its foundational underpinnings in automated reasoning. And in some ways, we're in a bit of a golden age for it because we finally have compute at scales that are unbelievable. I've been following some of the breakthroughs that have been happening from the team, but I'd love to hear, what is your introduction to why now? Why is this a great age for automated reasoning? And what is this technology now? We explain it to people as a differentiator.
So, thank you, Rohit. And I think that's a very important part to start with. Like, why is it a golden age for automated reasoning? It's been around for a long time. You call it formal methods and analysis. In fact, formal proofs have been around for thousands of years, not just decades. You had Euclid and Pythagoras proving things correct about systems. That's how long it's been. And the automated part really was about how do you automate that process. But still, it was very hard to do. You can imagine going through a complex set of deductive reasoning, thinking about like why is it correct, and then building these tools, techniques, algorithms was very targeted. It required a lot of deep understanding of the domain you're trying to verify, of the type of things that you are trying to prove correct, having and bringing it all together. And additionally, that was a very expensive endeavor. When I say expensive, I mean in terms of the expertise required to do it, the type of investment required to start it. So you only saw this really applied in very mission critical systems, aerospace, where the cost of failure is human life. Um, you had embedded systems like medical devices, again, cost of failure being very high. And for folks who remember the famous FDIV floating point error that Intel had um, back in the way back, that caused a lot of hardware companies and EDA companies to say, we need to invest in automated reasoning formal verification. But those were niche markets that did it. And what has changed to me, what's brought about this onset of the golden age, and I still think we're at the beginning of the golden age, we're not like in sort of in the middle of it, is this notion of the cloud. So like what makes cloud so different than our regular things
Mm.
is the like today it is really important that you have things correct. You are trusting your data, your workloads to be accessed over the internet. Can you imagine, over the internet? And but to do that, there had to be standardization such as APIs. There's no such thing that I can access that is not defined by an API. Clear interfaces, clear dimensions. And those two things in combination, the fact that the cloud brought about this onset of these clear interfaces, these APIs, made to the fact, oh, now we can model it. If we know what it is, we can model it, and then we can prove it correct. And why would we want to do it?
Mm.
Because we want to have the assurance that if I'm putting my data somewhere else and accessing over the internet, that there is no public access to this data under no possible condition. So these are the types of things I think it has created this. I call this like real world deployment at planetary scale, because that's what something like the cloud gives you. Um, it's not just in academia and research labs anymore, but we are seeing these proofs deployed at systems. One example is we have in AWS, we proved the engine that runs AWS IAM, we proved it correct. And so it's not just
Mhm.
proof in theory, the provably correct engine runs over 2 billion requests a second. And that's the scale that we've achieved. This is internally, and this we are doing across different systems, databases, storage, identity and access management systems. This is internal, like this is the security of the cloud. And everybody who's building on top of it, we're building services and other things where you can just go turn it on one click without ever having to know, without even ever having to take a math class in your entire life, and needing to know Greek symbols. And that to me was the key of my transition. I talked about these different chapters. That's how to me I went from being an academic or a research scientist to something that I, now proudly wear as a product developer tag, of making that available to the masses.
So I want to connect this to Cedar, because this is a live stream where we want to focus in on Cedar. So what's the connection between automated reasoning and Cedar, and how did that evolve? Because some of the first presentations I saw you do were about, I think, proving that S3 buckets weren't publicly available. And so was there an evolution somehow in Amazon where you were working on formal reasoning, or automated reasoning, and that somehow led to Cedar?
So I'll give the journey about how we got to Cedar. So AWS IAM is a authorization language system to control access to AWS resources. It is very targeted to, if you want to access AWS APIs, you use AWS IAM. But what we realized over the period, there's a wide variety of use cases where you cannot use AWS IAM because it's very targeted to the AWS cloud ecosystem. The fact that resources have an ARN, that services have certain actions and certain conditions. So if I'm building an application, a web application, I cannot go use AWS IAM because IAM does not provide you a way to give a way to define nouns and verbs of my application in IAM. It is for an AWS service. And even within Amazon, there was a bunch of people wanting a solution for access management that was not AWS IAM. We're like, okay. And so we started down this journey, and our goal was not really to come up with a new language at that point. So we're like, clearly, we cannot be the first ones thinking about wanting a different policy language to be able to do all of those things. So we went on this hunt. I call this a hunt, a discovery process. What exists? How do we use it? And turned out the real gap that we had was even the ones that could serve the use case did not have the security assurances, did not have the formal uh, underpinnings of saying, I can prove that this can never happen. The other problem was it was a lot of them followed the more is more. And I'll take, for example, let's start with Rego. Rego is very expressive. It's built on data log. It supports ABAC, RBAC, REBAC. And you can really model very complex hierarchies, recursions, data transformations. And but it doesn't have built-in concepts like, hey, allow these things, deny these things. It's it is hard for people to learn, and the way people really restrict is like saying, hey, we're going to have a restricted form of Rego that you can use. The performance can get unpredictable because it's very close to Turing complete, even in a restricted form. And if I wanted to prove security properties such as, hey, this can never happen, the fact that it was so expressive made it so that the Rego as a language could not be analyzable in a sound complete way. Even data log equivalence checking is undecidable. And on the other end of the spectrum, we had Zanzibar, which with OpenFGA was an implementation of. And that was, I would say, almost too restrictive because you had to like internalize the relationship model. You define user sources, and it was good for something that you had very restricted, such as like you're doing with Google Docs, which is where it was originally uh, come up with. And but it did not provide enough expressiveness for it to have to serve the use cases. And that's how we ended up with Cedar saying our goal is we support the basic authorization use case, RBAC, ABAC, make sure that it's built in, purpose built for authorization, has really high performance. Because as we've learned across our vast experience in authorization, how do you take like even less than 10 microseconds? But the real kicker was, how do you provide guardrails to the end user for them to not make a mistake? And that's where we came up with these, what we called the schema based validation, these policies being type checked against entities, ensuring that they never fail at runtime, and the analyzability. We designed an authorization language to be fully analyzable with only decidable fragments of SMT, which means you can prove, such as Rohit can never access this resource no matter what happens. And that was our journey from how we got to Cedar.
And that's a great segue there. I mean, I think I was once the PM, a product manager at Google for adapting Zanzibar. I'd both been started the company back when Zanzibar was being first created for social at Google Plus, and then moved over to cloud. And later on, worked on adding custom roles because guess what? Our number one of our top customer concerns used to be, hey, why isn't your security as fine grained and as flexible as Amazon's? So I'm like, well, because I'm trying not to ship a foot gun. If you know the old challenge about a customer shooting themselves in the foot. Well, you made a gun so heavy, the only good point is my foot. But Zanzibar was coming out of an example of relationship-based access control, and we've obviously had a huge set of histories between ABAC and RBAC, and even one area excited about formally as NGAC, Next Generation Access Control from NIST, right? The different mathematical unification of these. But when you did compare them, we mentioned some comparisons about various languages or approaches being restrictive or not expressive enough. I suspect part of it also is that we have a new kind of hello world challenge problem. We're no longer in the cryptologist's world of Alice and Bob have never met, but want to play poker while waiting to overthrow a government. They're not like, we're lovers, but we haven't actually trusted each other with anything except through a secret sharing system. Well, instead, photo sharing, Hello World in Cedar's Playground, it's in a lot of other systems. And it also speaks to some of the more modern challenges about a concept like sharing a whole folder with the people who are in the photos, but not anyone else. But you add a new photo and it has someone in it. What do you do? Or the photos are from a celebrity, or they come from the White House, and suddenly they need to be sent out to millions at once. And there's these these quirks and scaling factors. But when you step back and you say, look, comparing to approaches for relationship access control or graph-based access control generally, Auth-Z, Warrant, WorkOS, or Okta with its OpenFGA approach, what are some of the other ways you need to think about the whole system? Like, what's a good hello world to evaluate them when you want to add some meat to your comments about how you compare these languages? When I think about a complete solution, part of the problem is maybe we can't just write a principal action resource context truthful. We need to talk about the ergonomics of the whole system. The developer really wants to get the job done. Where is the object graph? How do I store pointers to all these photos and all these people and all these social groups? Or integration with other systems becomes factors. So what beyond the language choices affected here? When we compare it to Zanzibar, what are the limitations or comparisons of that? But more broadly, how do you go about judging whether you're meeting the customer where they are and providing a complete solution? Because for something like social photo sharing, or also if you think social photo sharing isn't a way to ground the rest of the conversation today, or the canonical challenge application, we should look at these languages for.
So I truly believe there's never going to be one silver bullet for everything. Absolutely. For example, let's say Rego. It is general purpose. Like if you wanted, and that is, but like it's a two-sided coin. And you can write rules that can evaluate structured input and data. You can write policies about CI/CD, security controls, and it can essentially become a policy about very rich things about your ecosystem, about your cloud infrastructure, about your pipelines. And if you want that, that's where you use Rego, because Cedar is not designed for that. Neither is OpenFGA.
Sure.
And that's that distinction. But if you're saying, okay, if I want a really fast, fine-grained authorization system that's looking through my photo sharing app and making sure I have the ability to evolve into where performance is going to be key. I want it to be quick lookups. People should not be waiting. If photographers have to have their own notion of sharing versus end users. Similarly, if there is a very clean way to say, hey, OpenFGA, which of course, I'm telling you what about it. If you have a relationship-based model, perfect. Like it'll be high scale, low latency in these collaboration-heavy apps. Absolutely, go use OpenFGA. But if you have a general purpose, fine-grained authorization need, like how do I get to fine-grained authorization, but in a way that protects me from shooting myself in the foot? That's where Cedar, that's the niche Cedar is for. It is for anything, and it's not restricted to AWS. That's the key. Anywhere, whether it's an app, whether it's a microservice, whether it's whatever cloud you are in, you want performant, high speed, correct, fine-grained authorization system. That's where you have Cedar. Rego is for something that you want super expressive, rich, roll your own policy as code. That's where you use Rego. But then if you have like these relationship-based things, use OpenFGA. So I think that's how I, in my mind, structure these three.
One quick follow-up, and I'll pass back to Mike. I hear you in possibly a very unique register, like a frequency only teenagers can hear, which is your flexible compute, any kind of attribute. I'm hearing like make computations based on the phase of the moon and the phase of your build pipeline. I often relegate myself saying the Turing tar pit. Like there aren't two sides of the coin. One of those coins is stuck to the ground and can't be pried off except with a steamroller because you pose a language that's fully computable. And I can't ever dig out of that one, because one of the advantages is Cedar is invertible. I can look at the equation and go backwards and solve for everything that can happen there. But the question that has a follow-up was, how do you so skillfully use your language and not fall into that level of invective I just did? The Turing tar pit, I don't know that's a term that works for people, or the question of the diversity in language that's so flexible and fun to use, but not realizing that it made it fully computable and very hard to analyze. Do you have a way of explaining the trade-off between languages, intractability versus expressivity versus computational power?
It's very anecdotal. I think this is going to be disappointing because I don't have a formal structure of how I define it. The anecdote is you'll make Cedar Turing complete over my dead body. Like that's one that's that is one form. But in realistic terms, how do we come up with the mechanics of keeping it not in that Turing hell computability notion, is by saying any feature that we add has to be analyzable. It has to be in the decidable segment of SMT. And that is our guardrail. That's our actual guardrail. Because you can have somebody well-intentioned add a feature to the language that can go against the grain of what we are trying to achieve with the constraints of the language. So that is our guardrail. So you may say, okay, you're going to disappoint people. They're like, but I want full regular expression matching. And it's like, why do you want it? Why would you would you want to degrade the experience? It's a security challenge. It's, you are unbounding your performance. Now you don't have those things. And
or you meet people where they are and you say, here's a kind of regex.
Here's the dependent. And oftentimes people don't know why they want it. This is my experience of why they really want a regex. It is something they know best. It's something that's available. But I would say 9 times out of 10, if you really dig into the case, they can achieve what they're trying to with a much simpler use case. And this is where I think it's important for us to really think about less is more. And it's hard to communicate that. And it's just keep asking why. I just keep asking why. Why do you need it?
I do. I'm 5 seconds, I'll hand it back to Mike. This is like a pachinko machine where if you drop the balls in the top and then you look at the ones at the bottom, you can't figure out which pins they hit. But a coin-operated authorization system where you drop it on the top and see what the decision is, yes or no, makes a huge amount of difference. I would say that the regular expression one of the other ways to really get people's attention that Amazon's products do is if you ever have an IAM policy or a Cedar policy that says organization 78 star, because I know that these two divisions both begin with a 78 prefix, I can move on. You in fact turn that into a warning that says you have just given access to the public because a regex is meaningless in this context.
Absolutely. And that's an actual example we use when we're talking about public access in about S3 block public access. If you restrict it to 078 star, that's meaningless because organization IDs are not handed out in order.
I can't resist the regex. I was going to move on to universal statements, but I just can't resist the regex conversation. And I want to point out that if input to policy is frequently a JWT token, and I've been advocating for a new access control mechanism called TBAC, token-based access control, with the idea that tokens provide the evidence and the provenance for that's very useful as input to policy. And the claims coming out of a JWT are strings. And a lot of times those strings need to be processed. And so I agree with you that Cedar should absolutely not do regular expression. I like Rohit's gumball machine. We want it to be reliable. But at the same time, I would point out that AVP probably does need some type of ability in order to break apart those tokens and let's say we get an email address, and that email address has a username and a domain, and we want to make a policy that says only users in this domain can get into this resource or call this API. So I would just maybe, what do you think about the role? Are you saying that regex if it's needed, should happen outside of, before you send it into Cedar, basically. And wouldn't you say that AVP needs some type of way, or probably has some type of way, to parse these tokens into smaller pieces to submit into the Cedar engine policies?
So a lot of these use cases, Mike, actually can be supported by checking for membership sets. Like, do you exist as part of this member? Do you uh, and searching in the entity hierarchy. The example that you have, like, hey, ensure that only folks from this domain can. That can be a membership query. So, and that gives you more structure without giving string overruns. And there is some rudimentary string matching in Cedar. It isn't full expression. um, it is expanded. It limits you what you can do. Now, to your point about AVP, that that's more an extraction rather than a matching. So um, we don't want to like push the problem somewhere else, because then we will have failed. What some like in token unpacking or something is doing is taking the data and then passing it on. The real engine, the analysis, has to be in the policy evaluation. Only then you know that you are getting the assurances and the guarantees that you want from your evaluation engine, both in terms of the correctness of the authorization, but also in terms of the performance. And I actually would argue that if you split it out, now you're creating more problems, because AVP is not the only thing that's going to use Cedar. There's going to be other engines. You can build your own service. You can also be using it within different analysis or evaluation. Like, you could build your own service around it. So you would absolutely not want to separate um, the workhorse in any way.
So you don't like the idea of
It,
parsing the token somewhere else and evaluating the policy? You'd want those to
You
be
can
together?
parse the token, but it should be purely parsing, not any semantic meaning to it. There, you're just giving it the request, like the request that goes to the Cedar evaluation engine. That's it, but not in terms of any intelligent or semantic meaning of what does this mean.
colloquially, say shredding is fine. It's all fun and games until someone recurses.
Yes.
Uh, Rohit, did you have a question, or should I ask my original question about?
Yeah, please do. That was my wrap up of saying that, I think very much the things you need to do can be done, but you have to think and meet the customer where they are. Sometimes they don't need the full power of regular expressions, recursion, and globbing, and the things that make it a tar
Exactly.
pit. In fact, what they need is just, separate username and email, domain and mailbox. We should build that in as a fixed primitive, and it helps with buffer overflow attacks, parsing attacks, a lot of other things too. So sometimes because we've been trained to use regexes as a hammer, it's seen as developer friendly, but it's analysis unfriendly, and so maybe we do have to slightly change what we want. So, Mike,
And I
I
want
think
to
everything you
double
want to
click
do
on
with
what
tokens.
Rohit said, just because a lot of times it's about how you design the system. It's like it's not even a hammer. It's like, what's those, like, sort of the
Claw machine.
yes, uh, because it's like, oh, I got it, so I use it. It's like, no. And
But it's always a prize if you don't know whether you wanted what you got in that claw
yeah,
machine with that regex picking something up.
Yeah, well, let's pivot back to. I feel like I'm diverting this to my own purpose, because this is parsing tokens is an issue I'm really interested in. Um, but I wanted, one of the things I learned yesterday was the idea of a universal statement, and how a universe. This is a quote from one of your previous live streams or videos. You said a universal statement holds over the entire universe of possibilities, not just what we've tested or fuzzed or observed or thought about. And I'm wondering, can we extend this to Cedar? And can Cedar actually help enterprises prove that their policies are secure by evaluating universal statements?
absolutely, yes. And that is one of the big, powerful features of Cedar. So this universal statement question that you're talking about is, when we started work in the, or like, it's part of, like, what do we prove correct about the cloud? And a few years ago, people were really worried about open S3 buckets. Like, hey, how do we solve this customer problem? People wanted to ensure that S3 buckets could not be configured to be
A lot of
public.
email addresses and identities sold with S3 buckets. So sorry, but yes, I agree. We want S3 buckets not to be public.
So, and that's a universal statement you want to hold true. You want to hold true that my S3 bucket is not public today and not ever in the future. The future part is very interesting because AWS is changing all the time. How do you ensure that AWS is not launching something that suddenly makes that universal statement not true? And that is the power of the reasoning that we brought in. How do you create this model and this proof of uh, anything? There's certain notions that AWS is not going to change. Like, it's not going to change what your regions are. It's not going to change what your actions are. It's not going to change how your VPCs are specified. So our whole notion of how we prove things are never public about your S3 bucket were based on creating this model of things that will never change. And saying if your policy restricts access in some meaningful way to only those constraints, if you restrict it to a specific VPC, then we know it, or a small range of VPCs. The cleverness and the analysis, the cleverness and the heuristics comes about is how do you ensure that the range is restrictive enough for it to not just be one specific thing, but a limited set of things, so that it's not misconfigured to be a public thing. And I've given a bunch of talks on this topic, so I won't go super deep into this, but it sounds hard on paper, but if the way we did it was we reduced it to logic, we reduced it to a analyzable fragment, and AWS IAM actually does have regular expressions and wildcards. So that made the problem a little more challenging, and how we designed our algorithms to ensure what was true and what wasn't. But what helped us was the fact that we knew the definition of AWS. We knew the semantics of AWS. It was not some unrestricted nouns and verbs of a system, photo sharing app today or something else tomorrow. And based on that, we came up with an analysis algorithm that says, here's how you're going to ensure and prove this universal statement always holds. Now, I talked earlier about the analyzability of Cedar. So why did we start with the design of it? This reinforced, we launched the Cedar Analyzer as an open source thing. So for anybody who's looked, there's this S3 block public access work is based on a analysis engine called Zelkova. It's an internal only tool, but we've talked about it publicly in a lot of different forums. And the Cedar Analyzer is the moral equivalent of Zelkova, which we've launched as open source. And that goes to Mike's point. The reason we did it is if you're an enterprise or a startup or anybody, or just a containers nerd looking to build an authorization in to your system, fine grade authorization, but want to ensure that any time a policy has gets more permissions added onto this, I want to ensure that I get a notification. And you could build that Cedar Analyzer into your CI/CD pipeline so that anytime you commit a policy, that can be run, and you can check and prove that something you don't want never happens, or prove something that you always want to hold true, a universal statement actually does. So that is the power of taking Cedar that turns into this analyzable part to SMT. And that's where the analysis runs, and that's what helps us get this assurance that this universal statement holds.
I think obviously very exciting stuff, similar to the journey from moving from Zelkova and specific statements. Again, computers to the system.
Rahit, we lost you. Sorry, we lost you for a second, Rahit. I hate to do this, but I'm gonna go to the next question. Rahit, we're just gonna, you're frozen. I'm gonna just ask Neha the next question, or a next question. I'm sure he was going somewhere.
We can come
Brilliant.
back to it. We can take it back. We can turn back.
Maybe I could talk about the scale question. Does this scale, or what are some of the challenges around scaling this type of reasoning approach?
So this it's a really good question in terms of like the scale is different in terms of we think analysis like evaluation in terms of less than a few microseconds. Like that's where we want our authorization results. This is like, hey, should this person have access or not, like when you're calling the engine. But when this other analysis is what we think of is something you'd want to do async. You're not necessarily running it in your data plane requests. You're not running it as part of your authorization request. And in the async forum, we still work very heavily to ensure that it's within a few seconds. So it can be run in your CI/CD pipelines, and we think of these analyses more as control plane operations. When you update a policy, when you check in a policy, when you create a policy, those are the times this analysis is actually run. Uh, and that's how we think about the separation between the analysis. And this is where we spend a lot of the science cycles trying to figure out how to ensure that your analysis completes in timely manner.
Okay, I see. Rohit, you're back. Are you back? I'm going to move on to the next question. I really enjoyed the recent presentation you did with Jim Scharf from MongoDB. And the question is sort of about adoption. One of the reasons OPA, I think, has been so successful is because they got good adoption in the Kubernetes access control business or sector. And what excited me about the MongoDB presentation and how they've deeply integrated Cedar for fine-grained authorization into MongoDB is that I wonder if data and access control of data might be like the killer application for Cedar. But could you talk maybe about why you think database access control or authorization might be a good fit for Cedar?
Yeah, absolutely. So going back to your point is the fact that data is data is everywhere, right? Like, so, and it's going to come down to fine-grained authorization, row column level access, building different layers of access management onto data stores. And that's where you want clean, fast, either attribute based access control, or you want role-based access control, but for it to be very quick. And less is more. You don't want to have to be able to write a full function that evaluates whether access should be granted or not. And so data access is a perfect example for it. I actually think even for Kubernetes and containers, Cedar is a fantastic example. We have a couple of advocates in the containers world pushing for how can we get a Cedar implementation for Kubernetes. There is one open source as well that's by Michael Lewis, who's very active in that containers world. But in these environments of whether it's data access, agentic access, like agents will be accessing a lot of things on your behalf. Also, if you have building applications, web applications, whether you're doing machine to machine authorization, you're doing it in a hybrid environment, you're doing it in an environment that's across on-prem systems, multiple clouds. All of those use cases we believe are critical and can really benefit from Cedar.
I feel like one of the underappreciated features of Cedar is schema. There's a lot of emphasis put on the ergonomic syntax, so how easy it is to read Cedar. Although when I look at the Rego side by side, I'm not always sure that the Rego is like that much harder to read than the Cedar.
Mhm.
They're simple policies, um, and but I feel like the schema is really at the heart of one of the powers of Cedar. Do you also feel like the schema is underappreciated, and do you feel like that's a differentiator versus OpenFGA and Rego?
So I'll tell you, like the schema is one of those people are like, oh, I have to write a schema. That's too hard. Like I have to figure out what my application actually does. And that's, it's people often struggle there the most, but once they have it, it's like the world is their oyster, because once they have the schema, they get the power of validation. They can ensure that every policy that is authored is correct and based and useful for that application. So to your point, is that the differentiator? Absolutely, but it also creates a bit more work for the users up front. So it's not a populist feature. And that's the part of it that I think makes it underappreciated, because nobody's like, yay, schemas. They're like, oh, I gotta
Hmm.
write schemas. It's
But
only after
maybe in the
you reach
database
the other
world,
side of the ocean, you're like, oh my god, schemas are awesome.
But maybe in the database world, it's very natural to have a one-to-one mapping, and it's almost like the 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 organization or sort of structure of the data in a database is what makes it complicated. And without the schema, maybe how do you really know that you're going to be able to model it?
Exactly. But it's still just because, it also creates a, why can't I just do it like in a Java program? I don't need anything else. I can just write my authorization in a Java program and not force me to think about my nouns and verbs and my entities, which is essentially what the schema is forcing you to do. And but once you do it, I think our next step will be how to help people come up with the schemas. Your point is absolutely valid. For databases, it's a one-to-one mapping, but like maybe this is one area we want to really experiment more in. How can we leverage things like LLMs to help uh, at least get you this first 70% there, based on all the artifacts you have, and then based on that, start to generate your policies. So I think there's a lot there with where we can but sorry, where we can be doing more to
Mm-hmm.
help people appreciate uh, the power of the schemas by helping them get started with their schemas.
Rohit, we'll just go over a minute since we got disconnected. Last question, Rohit, before we go to last thoughts.
Well, I was curious about what the journey has also been personally. There's a kind of very much a technical dimension to this, and I certainly will phrase it in the form of a technical question. But at some point, to make a change from Daphne being the back end for theorem proving to Lean. And the point isn't to ask the audience to follow along with the technical side of it, but what are some of the milestones in your story about growing the technology on the Amazon Science side, and then becoming part of the product team on the identity and reasoning and identity side, and collaborating now with other parts of Amazon, actually doing reasoning for networking and reasoning for compliance and governance? How do the people problems change? Right? What do So given the context
I
of
think
some of
we may
these,
need a whole different podcast for that. There's so many layers to that question.
but just for Daphne versus Lean, did you have to bring people along? Can you explain what it was, or there's a better example of like a case where you're evolving the language and being a steward of both the internal and external product, and how do you learn to balance the needs of Amazon and the Cedar community?
Yeah. So our choice for Daphne versus Lean came down to a very, and to for the viewers who don't know, we started with a proof of correctness in Daphne, and the reason for the switch to Lean was we wanted to extend proving correctness not just to the authorization engine. But also to the evaluator, to the validator, the schema validator that you have, and as well as the symbolic evaluation engines. And the meta theory required to prove the correctness of that was something that lean was very good at, and that was our choice for saying, hey, because we're gonna expand what we are proving correct, and these all these lean proofs and models are available open source. So if you go to Cedar, to this GitHub Cedar repo, you can see all of them, including the symbolic evaluator proof. And that was our main reason for switching to your organizational problems. I think at the end of the day, this comes to more of a technical question, like what's the right tool for the right problem. And then the people problem is, are you um, are you set up to ensure that you can maintain and sustain this in a meaningful way to so
Rohit, why don't I give you last thoughts, because I want to give Neha last thoughts. But Rohit, any thoughts, last thoughts on this conversation?
Well, I mean, I am most interested about not just where we've gotten to with this technology in 2025, but I have thoughts both for her and for the community at large, or how can we bring us to 2026? And we live in an era where there's a lot of AI and a lot of new potential. And meeting people where they are sometimes easiest done in plain English. And so my thoughts are, as we both are explaining ideas that are pretty behind the scenes computer science, the real accomplishments of this team have been in meeting users where they are, meeting domain experts where they are, not having them learn new languages. And I think the ultimate there I'm looking forward to is seeing interesting research on guardrails and natural language processing and integrating this into, as they have automated reasoning for Bedrock. So I hope that we can bring the power of these approaches to more people by putting it even easier to use and maybe working directly with documentation people have for their governance and policies. So policies in plain English is my big hope out of this.
Awesome. Neha, last thoughts?
My last thought is, like, as I want to double click on a couple things that Rohit said, is as we move on to this new world where LLMs and other things are a big thing, there is a power to determinism, where how do you keep your deterministic tools? Your authorization engine does not need to be an LLM, but an LLM can use an authorization engine. And that's the separation I want people to be thinking about. Just because we have a tool, a hammer, we don't need to use it everywhere. And by this, I mean LLMs. But there is a power to, like, how do you go from a natural language to an actual policy? Because then once you have a policy, you can run it, evaluate it deterministically. Here's where a schema validator helps you. Here's where the tools help you. And I like, my final words would be, don't roll your own authorization. It's not a good use of time. It's the security ramifications, your correctness ramifications. In the same way, most of us don't roll our own operating systems and databases for the most part, and authentication systems. We are there for authorization, and really, really think about your next steps there.
Awesome. Okay. Well, we could go on a lot longer. I want to just quickly announce next episode, and just mention that our guests are from Australia, so we're doing it a little later. Next episode is on the topic of outsiders within managing access in the extended enterprise. It'll be at 3 p.m. Pacific, a little later than normal. That's coming up on Thursday. With that, I will say thank you to the guests. Thank you, Neha. Thank you, Rohit. And thank you, audience. And we'll see you next time.